For those trapped in their own bodies by severe paralysis, a glimmer of hope is emerging from this operating room in Michigan. Austin-based Paradromics tested its Connexus brain-computer interface, or BCI device, for the very first time in a human, with the promise of reshaping the future of medicine. How big of a deal was this recent surgery?
It's a big deal.
Paradromics CEO and founder Matt Engel says it's a critical milestone that moves Paradromics' BCI platform one step closer to changing lives, with human trials to restore speech in patients with severe paralysis.
So our Connexus BCI platform has been tested previously in sheep, but the one thing that we haven't done yet is use the device in people and record signals in people. And that's what we did just a few weeks ago.
The opportunity came during a pre-planned epilepsy surgery. Thanks to the generosity of a volunteer patient, the team had a small window to test their system.
We were able to take advantage of that, and then we took the device out, and everything was safe and happened in less than 10 minutes between putting the device in and taking it out.
So how do you implant a device that can read your mind? Paradromics Chief Medical Officer Dr. Stephen Rue walked us through the procedure. It begins with a small opening in the skull. A high-precision arm then positions a unique spring-loaded device over the exact part of the brain controlling speech.
This arm allows us to place it right over the brain exactly where we want it to be. Once it's there, we're able to then deploy and implant the array.
That array, called a cortical module, is the heart of the system.
This is the device that's implanted on the surface of the brain, and you can't see it right now, but here at the edge of the device, you have 421 platinum iridium microwires. Each one of these wires is less than half the width of a human hair and can be implanted into the brain without damaging the brain tissue. And by virtue of reaching down into the layers of the brain, it can record from individual neurons. And that level of resolution to record from individual neurons is what allows you to build a high data rate brain-computer interface.
That ability to listen to thousands of neurons all at once is what unlocks a stunning amount of information. In animal studies, Paradromics' device achieved data rates north of 130 bits per second. For comparison, Matt Engel says that is 10 to 20 times higher than the 5 to 10 bits per second reported in Elon Musk's Neuralink BCI trials. But beyond the impressive technology, Dr. Rue says the company is guided by one unwavering principle.
At Paradromics, patient safety is not just a talking point, it is our North Star. Everything we do is based around trying to ensure that what we do is safe, but also the operation itself is as safe as possible for the patients.
With this successful human procedure complete, Paradromics is now focused on a future where no one is locked in silence.
We see that the first thing that we can do with this technology is restore communication for people who have lost the ability to communicate. But the overarching goal of the technology is much larger. Essentially, if you can move data between brains and computers, then you can reframe a lot of hard-to-solve biology problems as solvable technology problems.
Thank you for watching. Please hit the subscribe button and get the latest news by downloading the CBS Austin News app.